Laws of motion, Newton 3 laws of motion. In the past, before Newton Baba, scientists believed that there is only one natural state of any object. For example, consider this ball at the rest. Scientists believe that this is the natural state of the ball. Secondly, consider this car at the rest. Scientists believe that this is the natural state of the car. On the other hand, scientists believe that objects stay in motion only if they are pushed or pulled, but eventually the moving body would come to rest, which is the natural state of any object. Let me repeat it. Scientists believe that objects stay in motion only if they are pulled or pushed, but eventually the moving body would come to rest, which is the natural state of any object. In conclusion, they thought that everything in the universe is in the natural state of rest, or every moving object in the universe would eventually come to its natural state of rest. This concept of natural state of rest was totally wrong and it was rejected. Later, Newton Baba came, who presented 3 laws of motion. Now, what is the first law of motion? Well, we can easily understand Newton's first law of motion if we divide it into 2 parts. Firstly, Newton Baba states that every object has 2 natural states. Either it will remain in a state of rest or it will remain in a state of uniform motion. Note it down that in uniform motion, the net external force on object is always 0, or we say that F is equal to 0. Now consider this ball at the rest. According to Newton Baba, this state of rest is the natural state of the ball. Secondly, consider this car. That this car is moving in a straight line with uniform speed. According to Newton Baba, this uniform speed or uniform motion of this car is also natural state. Secondly, Newton Baba states that if you want to change natural state of any object, you need external force or unbalanced force. For example, consider the ball at the rest. When you kick this ball, you exert external force on the ball. As a result of this, you change the state of rest and the ball starts moving. After covering some distance, the ball will stop. Here, let me ask you, what is stopping the ball? Well, the answer is simple. The friction force of the ground is stopping the ball. If we eliminate the friction force of the ground, the ball will continue its state of motion forever. Secondly, consider this moving car. When you suddenly apply brakes, you exert force on the car and you change the state of uniform motion of the car. As a result of this, the car stops. Therefore, Newton Baba states that a body in rest or uniform motion will remain in its natural state unless acted upon by external force. Remember that if a body is in natural state, the net force on the body is always equal to 0. Some very talented people and very famous book write F is equal to 0. Personally, I do not like this. I always write net force is equal to 0. Secondly, we can also say that if net force on a body is 0, a body will remain in its natural state of rest or uniform motion. Thus note down these important points about Newton's first law. Now let me teach you the application of Newton's first law in everyday life. Consider some books present on the table. We know that these books are experiencing the downward force of the gravity. Let this is 10 Newton force. At the same time, the table is exerting upward force on the books. Let this is also 10 Newton force. Now let me ask you, what about the net force on the books? Well, the net force on the books is 0, so we say that these books are at rest, which is the natural state of the books. Secondly, consider the jumping of a paratrooper. We know that this person is experiencing the downward force of the earth, that the downward force on this person is 500 Newton. Also we know that at the same time, the air resistance is pulling this person in upward direction. Let this upward force is also 500 Newton. Now let me ask you, what about the net force? Well, the net force is 0 Newton. But we know that this person is still in uniform motion, or it is moving with uniform speed towards the earth. Here, a lot of students are confused. They think that if the net force is 0, then why the paratrooper is moving with uniform speed towards the earth? Well, the answer is simple. It is due to inertia. If you want to understand inertia, I always connect it with the mother. We know that every mother cares about her children and she wants to keep their children in good health. Similarly, inertia always wants to keep any body in its state of rest or in its state of uniform motion. One can also say that inertia tends to keep the body in its initial position of rest or initial position of uniform motion. For instance, initially, the paratrooper was moving in downward direction. Even the net force on the paratrooper is 0, but inertia tends to keep its uniform motion in downward direction. Remember that if a body is at rest, the net force is always 0. Secondly, if an object is in uniform motion, the net force is again 0. So in Newton's first law of motion, we learn that there are two states of any object. The first one is state of rest and the second one is state of uniform motion. Now here, Newton Baba thought that what would happen if the net force on an object is not 0? To answer this question, Newton Baba presented his second law of motion. We know that if the ball is in the rest, it is its natural state, and the net force on the ball will always be equal to 0. Secondly, if the car is in uniform motion, it is also its natural state, and the net force on the car will also be equal to 0. Now Newton Baba states that if we exert force on this stationary ball, force will change its velocity. For example, initially the velocity of the ball was 0. After exerting some sort of force on it, let its velocity change to 5 meters per second. We know that when velocity changes, acceleration produces. So indirectly, Newton Baba states that when net force is not equal to 0, it produces acceleration. Let me repeat it. When net force is not equal to 0, it produces acceleration. Secondly, when we suddenly apply brake, we exert force and the car comes to rest. Again, Newton Baba states that force changes velocity of the car. For example, let the initial velocity of the car was 30 meters per second. After exerting some sort of force, the velocity of the car is 0 because it has stopped. Here, velocity is changed. We know that when velocity changes, acceleration produces. So indirectly, Newton Baba states that when net force is not equal to 0, it produces acceleration. Therefore, acceleration is directly proportional to the applied force on a body. Secondly, he states that acceleration is inversely proportional to the mass of a body. Are we right? F is equal to ma. For example, consider this car and this truck. Let the mass of this car is 100 kg and the mass of this truck is 200 kg. Let I exert 200 Newton force on this car and I also exert 200 Newton force on this truck. We would observe that the car will start moving with acceleration of 2 meters per second square and the truck will start moving with acceleration of 1 meter per second square. Here, the truck is moving with acceleration of 1 meter per second squared because truck is 2 times heavier than the car. So that's why we say that acceleration is inversely proportional to the mass of an object. Thus noted down all these important points of Newton's second law. Now let me teach you the applications of Newton's second law of motion in daily life. Remember that every accelerated object is explained by Newton's second law of motion. For example, when you kick a ball, you exert force on it and the ball is accelerated in the direction of applied force. Secondly, when we push accelerator of the car, we exert more force on the car body. As a result of this, acceleration or speed of the car is increased. Thus remember that every accelerated object is explained by the help of Newton's second law of motion. Now what about the Newton's third law of motion? Remember that Newton's third law of motion is all about physical interaction between two objects. For example, when you sit in a chair, your body exerts a downward force on the chair. Let it is 600 Newton. At the same time, the chair is also exerting an upward force of 600 Newton on your body. Due to physical interaction between your body and the chair, two forces are generated. These two forces are called action and reaction forces. Therefore, Newton Baba states that for every action, there is an equal and opposite reaction. For instance, the magnitude of downward action and the magnitude of upward reaction is the same, which is 10 Newton. But remember that they both have the opposite direction. Thus remember this third law of action and reaction. Now let me teach you applications of Newton's third law in our daily life. Consider a moving airplane. We know that engine of the airplane forces the air in backward direction. It is an action. As a result of this action, airplane will move in forward direction, which is a reaction. Secondly, when we walk on the ground, our foot exert backward force on the ground, which is an action. As a result of this, the ground exert equal force on our body in forward direction, which is a reaction. Thirdly, consider launching a rocket. A rocket engine produces downward force, which is called downward thrust. As a result of this, an upward force or upward thrust is produced, which move the rocket in upward direction. Thus, these are the different examples of Newton's third law of motion in our daily life. I hope that you have learned all about the laws of motion.